friends, my name is Jayant. Welcome to Maths with Jayant. Today we are going to learn about equivalent fractions, and we will also learn how to simplify fractions. This is reducing a fraction to its lowest terms. You can call them whatever you want. So let us start with today's topic. So let us start with equivalent fractions. So what are equivalent fractions? Equivalent sounds like equal. So like equal fractions or fractions that have the same value are called equivalent fractions. But what do I mean by same value over here? Let us understand. So how much part is colored in this? How much part is colored? One part out of two is colored. So right now we have 1 by 2 or 1/2. Now let us take another example. So now how much part is colored over here? We have 2 parts out of 4 colored. We have 2 parts out of 4 or 2 by 4. Now you know what? These pieces are of the same size. They are of the same size. So if I keep them together, then they will be of the same size, like this. And even the piece is the same for both that I have used. So like this becomes 2 parts out of 4 for this. Yet this is 1 by 2. This is 1 by 2 for this. So over here you can see how the parts are equal. They have the same value. So such fractions are equivalent fractions. Both of these fractions have the same value. So now we've understood equivalent fractions. So let us see how can we make equivalent fractions. So now let us know how to make equivalent fractions. So suppose you are given a fraction, say 2 by 3. You have a fraction 2 by 3. So how do you make equivalent fractions? Like find fractions that are equal to 2 by 3. So what you can do is that you can multiply the numerator and the denominator by the same number. Like I multiply 2 to the numerator, I also multiply 2 to the denominator. Like this, 2 into 2 gives me 4, 3 into 2 gives me 6. So 4 by 6, 2 by 3 and 4 by 6 are equivalent fractions. We can find one more equivalent fraction. Let's take 2 by 3, we can multiply both by 4 or by 5. You can multiply by anything as long as you multiply the same number to both. Let me multiply 6 over here. So 2 into 6 is 12, 3 into 6 is 18. So we have got 12 by 18. So all these 3 are equivalent fractions. So like this, the first way we got to know. If we multiply the numerator and the denominator both by one number that's the same, so like this, so then the fractions are going to be equivalent. And you can even prove it like 2 by 3 is 2 parts out of 3 and 4 by 6 is 4 parts out of 6. They both have equal parts shaded. Okay, now let's know about the second way. Let's take a big fraction this time. Let's take 80 by 120. So we've taken 80 by 120. So over here, let us this time divide. 80 and 120 both are divisible by 10 because they both end by a 0. Like this we get 8 by 12. They both are also divisible by 2. They are divisible by 2 also. So like this we get 40 by 60. So right now we've got 80 by 120, 40 by 60, 8 by 12 as they are also equivalent. So like this we understand that if we divide the numerator and denominator both by one particular number, so then the fractions will be equivalent. As long as you are dividing or multiplying by the same number for both the numerator and the denominator. If you are multiplying to the numerator, we have to multiply to the denominator. If you are dividing to the numerator, you have to divide in the denominator also. Then only they will be equal. Now let us solve a few questions. So now let us solve these questions. So what type of questions do we get? So these sort of questions are, we are given one fraction and we need to find an equivalent fraction for it, where either the numerator or the denominator will be given and we have to find the missing number. So how do we do this? Let's start off with our first question. 3 by 4 and something by 8. How do we find this something? Let us see. So 3 by 4 is equal to something by 8. Over here we have both denominators or both the numerators. We have both the denominators. With the help of the denominators, we will be able to find the numerator. So this is because we'll multiply something to this to get this. And we know that 4 into 2 gives us 8. And if whatever we do in the denominator, we should do the numerator also, so that the fractions are equivalent. So we multiply 2 to the numerator also. 3 into 2 gives us 6. And like this, we found out the missing number. Wasn't it easy? Let us solve another question like this, where 7 by 9 and 14 by something. So over here we have both the numerators this time. So we will take the help of the numerators to find the denominator. So 7, and this is bigger, so we will have to multiply something to 7 to get this. So 7 into 2 gives us 14, we know. So whatever we do to the numerator, we have to do to the denominator also to keep the fractions equivalent. 9 into 2 gives us 18, and so we found the missing number. Let us solve our third question. 20 by 80 and 4 by something. Over here, both the numerators are there. So 20, this is smaller, so we divide something. We divide 20 by a number to get 4, and we know that 20 divided by 5 gives us 4. Whatever we do to the numerator, we have to do to the denominator also to keep the fraction equivalent. And 80 divided by 5 gives us 16. So the missing number is 16. Let us solve our next one. Over here we have both the denominators, 35 and 7. This is smaller, so we will divide something to 35 to get 7. 35 divided by 5 gives us 7. So 15 divided by 5 we have to do. 15 divided by 5 is 3, and so like this we found the missing number. So now we have learned how to do this. Now let us move on to our next part for equivalent fractions. So let's see. Over here we are going to check if the two fractions are equivalent. 6 by 10 and 9 by 15 are equivalent or not. Like this we are going to check if these fractions are all equivalent or not. So let's solve. Let's start with the first question. 6 by 10 and 9 by 15. How do we check if these two are equivalent? So to check if two fractions are equivalent, we use cross multiplication method. Cross multiplication. That means this into this and this into this. So 6 into 15 and 10 into 9. These two should be equal. 10 into 9 is 90, 6 into 15 is 90. As these two are equal, so these fractions are equivalent. Let us solve this. 7 by 14 and 5 by 10. So over here we are going to use cross multiplication. This means that 7 into 10 should be the same as 14 into 5. 7 into 10 is 70, 14 into 5 70, as these are equivalent, so these fractions are equivalent. Next one, over here you will have to be dealing with big numbers, 12 by 16 and 9 by 12. How do we check if these two are equivalent? Use cross multiplication. 16 into 9 should be the same as 12 into 12. So like this, 16 into 9 gives us 144, 12 into 12 gives us 144. And as both of them are the same, these fractions are equivalent. 5 by 7 and 15 by 21. You use cross multiplication to check. This means that 15 into 7 should be 21 into 5. These two should be same. 15 into 7 is 105. 21 into 5 is 105. As both of them are equal, these fractions are also equivalent. Let us have a look at another example. 3 by 4 and 8 by 11. This is our fifth example. So we use cross multiplication. 3 into 11 should be the same as 4 into 8. 3 into 11 is 33. 4 into 8 is 32. As we've not got the same answer, these are not equal. That's why these fractions are not equivalent. So this is how we check if two fractions are equivalent or not. Let us move on to simplifying fractions. So now let us discuss about simplifying fractions. So let me show you two fractions over here. 1 by 3 and 3 by 9. So this is first set. Or 2 by 7 and 6 by 21. Or let me show you one more. 4 by 6 or 400 by 600. So I am showing you all these sets. So which one is easier for you to understand? 1 by 3 or 3 by 9? 1 by 3. 2 by 7 or 6 by 21? 2 by 7, right? And 4 by 6 or 400 by 600? 4 by 6. Correct? Why is this? Because these fractions are smaller. They are simple to understand. So this is the big fraction. All these are big fractions. So it becomes hard to understand. All these are sets of equivalent fractions. All these fractions are equivalent. But we can understand a simplified form much more better. So let's see how to find a simplified form of a fraction, or let's see how do we simplify fractions. So let's see how do we simplify fractions. So let's take a fraction. Let's take a simple fraction first. 16 by 20. So we have taken 16 by 20. So actually there are two ways of finding a simplified form. First of all, what you do is you just divide by one number and you get the simplified form. Or the other ways that you do repeated divisions. So you are going to be performing repeated divisions and then you will end up with the simplified form. So let's see. So let's start with this method, where you just divide by one number and you get the simplified form. Now what should this number be? This number should be the HCF of the numerator and the denominator. If you don't know HCF, you can watch my video on HCF and LCM by clicking on the I icon or by clicking on the link in the description. So let us find the HCF of 16 and 20 directly. So the HCF of 16 and 20. If we prime factorize, we'll get 16 as 2 into 2 into 2 into 2. 20 is 2 into 2 into 5. So we have two 2's common over here. So the HCF is going to be 2 into 2, which gives us 4. So the HCF for both is 4. So we can divide by 4. 16 divided by 4 is 4. 20 divided by 4 is 5. So we've got this simplified form. But suppose if you don't know the HCF of two numbers or the numbers are big, so you can perform repeated divisions to find the simplified form. Now 16 and 20 both have the common factor of 2. We know 2. 8 by 20 divided by 2 is 10. 8 by 10 again have common factors of 2. Like this we get 8 divided by 2 4, 10 divided by 2 5. And we have got the simplest form. Now comes a big question. How do we know this is the simplest form? Like, why couldn't you think that 8 by 10 is the simplest form? How will we know the answer that you got? Is it the simplest form or not? So what you are going to do is that you are going to check if the numerator and the denominator, if they are co-primes. Now what are co-primes? Co-primes are numbers whose LCF is 1. To know more about co-primes, you can watch our video on prime and composite numbers. Okay, so like this, we get co-primes. So 4 and 5 are co-primes. Their HCF is 1. So it is the simplest form. But what about 8 and 10? The factors of 8 are 1, 2, 4 and 8. The factors of 10 are 1, 2, 5 and 10. They both have 1 and 2 both in common, so their HCF is 2 and not 1. That is why 8 by 10 cannot be the simplest form. They still have 2 in common, so you can divide some more numbers to get the simplest form. Now let us solve another question to understand simplifying fractions more properly. So let us take 80 by 160. This is a big fraction. Let us start off with the repeated division method. So 80 divided by 2. Both are divisible by 2. So we can say 40 by 80. They both are also divisible by 2. Like this you get 20 by 40. 20 by 40 are again divisible by 2. Like this you get 10 by 20. And let me write that 10 by 20 are again divisible by 2. Like this you get 5 by 10. 5 by 10 both are divisible by 5. Like this you get 1 by 2. And so 1 by 2 is the simplest form. But you can see how many repeated divisions we made. 2, 2, 2, 2, 5. And then we finally got the simplest form. So let us directly divide the number by the HCF. So we will be finding the HCF of 80 and 160. So 80 becomes 80 and 160. The bigger number is divisible by the smaller number, right? 160 is divisible by 80. So the HCF in this case is 80 itself. So you can directly divide both the numbers by 80 and you will get 1 by 2. You see how much easier it is to find the HCF and divide. So hope you understood equivalent fractions and simplifying fractions. But before we end, let me just show you two fractions. 5, 4, 1, 2, 3 by 1, 0, 8, 2, 4, 6. Or just 1 by 2. Any day 1 by 2 is easier to understand. No, this big fraction. Both of them are equal. So you could also say that this is equal to this. But can you understand that how much easier it is to understand the simplified form? So like this we can understand the importance of simplified form. That it is so important that we can understand this simplest form. Because this, understanding this fraction is really hard. Okay, so thank you very much.
Thank you for watching. Please like this video, share it, and subscribe to my channel for more videos. Thank you.